Again, I apologize for interrupting your flow.
That's okay. Let me actually do that a little bit bigger since we have space. So, I think this is the simplest matrix we can get, which is, say, 7. 3, let's say 2, 1, 0. Let's say we have another 2 here and a 4 here. Oh, actually, no, let's put this, to 1. So in this matrix, we need the rabbit will start in the center, right? That's what we said. That's what the problem said. Where did you say that?
Line 5? Wait, no.
But this is
Line 3.
Line 3. In the middle of the matrix. So the middle here, and let's put the indices again here. I keep forgetting that I can't write that. That high. So let me just move this here, and then let's do this. This is 0, 1, 2, 0, 1, 2, right? So the matrix, the middle of this matrix will be number 7, which is at X and Y. Let's keep going with that. This is X. This is Y. It'll be 1, 1, right? So we have this, we start at 1, 1. Then from there, where should it move?
It should move up to 5.
Why should it move up to 5?
Sorry, the background noise here. Because 5 is the largest number in the grid around 7.
Mm-hmm. Right, so if we go back to the points here, we set this point. On each iteration, the rabbit can move up, left, right, or down. So basically what that is saying is the rabbit can only move here. The rabbit can only move here, there, right? And from there, so somehow the rabbit has to sort of scan the area, see which one is the highest, and then move there, right? So we're gonna need to, the rabbit will need to check its surrounding area, top, bottom, left, and right. Pick the biggest one and then move there, right? So we saw that then here, the next position will be, I think it's, the next position will be, this is X. One, 0. Cool. So now imagining the rabbit is here, where can the rabbit go from there? Let me change the color.
To the right.
It can, right. We want it to go here, but thinking that the rabbit. So here the rabbit was here, right? At first. Now let's think about, now the rabbit is here. Now it can move. It can move here. It can go back. Well, it wouldn't go back there just because that gets set to 0, but it could do this, right? If there was something else here, then it could move there, but there's nothing else we can go.
You need out of bounds conditional just in case.
That's correct. We're gonna need to check so that right, because that's actually a point that we're gonna have to cover. We know that we can just sort of draw this cross from the center of the rabbit, but we need to check that each element in that cross is inside of the bounds of the matrix so that we don't get an error. Okay, any questions up until this point?
I have a question, because why would it be able to go back to 7? if that's going to be 0 now, no?
Right, that's correct. So we will set this to 0. So I just said, just imagining that the rabbit can always go up, down, left, and right. But that's another point. Actually, we should be keeping note of that. So check out of bounds. And that's another good point about it shouldn't go back to 7 because that is set to 0. So we also need to check. So here we're starting to think about, well, all the possible moves or all the possible locations that the rabbit can go to must be inbounds, and the value must be greater than 0, right?
And the biggest value of the options.
Mm-hmm. So let's do something like for all possible locations. Let's say location must be in bounds. Must not be 0. And it has to be the highest, right? That's what Shara said. Highest value. Okay. I guess then we can we can erase this part because the check out of bounds is already like here. So we need a way to get all the possible locations and do this check for all of them. Check that is inbounds, check that is not 0, and then try to figure out which one is the highest value, right? Okay, so then this one was pretty simple because we have a defined middle. But any questions up until this point? So let's leave that one there. Go back here. What about a matrix that is? Yep.
So let's say if it wasn't a perfect like 3x3, let's say it was uneven like 4x3.
Mm-hmm.
If we want the biggest center, would we have to compare the ceiling and the floor?
What do you mean by the ceiling on the floor?
Like mat dot. You know how you get the center in the 3x3, but since there's not really a true center in a 4x3.
Mm-hmm.
You have to either get the ceiling or the floor. So would you have to compare the ceiling and the floor to get the biggest one, or it doesn't matter? It doesn't matter.
We're gonna need to compare, but I don't think the ceiling on the floor will be the right way to word it. It will be like the way it's worded here. If it has multiple possible middles, then choose the one which has the highest value. So the problem that Ken is mentioning is this one, where we have this matrix with 0, 1, 2, 3, 0, 1, 2, right? Here, well, the way in which we calculate this middle is, well, this one is easier to spot, but basically we have the length. Here, let's do that a little bit more here. So I'm actually gonna go with the same sort of rows and columns. So we say rows, which is basically the length of the inner array. That will, in this case, is 4, right? And let's say columns. Columns. I'm just gonna say cols, right? Oh, sorry. Rows we have 4. Columns, rows we have 3. Columns we have 4, right? Now the way in which you could calculate that is, then let's divide them by the middle. Let's divide them by 2 and see what we get there. That's basically what we had here. Like here we did, we have 3 columns, 3 rows. We do 3 divided by 2. That's 1.5, right? 1.5 is not a valid index, so we need to floor that. That gives you 1, and then that's going to be 1, 1, right? Here we're going to need to do the same thing. So let's say middle. Here, I guess let's do. Oops. The rows in the middle will be, that will be easier. That will be, 3 divided by 2. That's just equal to 1. I'm doing the math floor automatically. Then we have here 4 divided by 2. We get 2. Right, so then that will give us, so actually let me put here rows, columns will be like our X. Columns will be our X, rows will be our Y. Let's say X here, Y here. So this will give us, I guess I could put here. Rows is X, this is Y. So this will give us 0, 2. Wait, no, I'm getting confused. 0. If we do X, Y, where we have 1 and 2, then that gives us a 1, and then 2, which is here. This is not the middle. Basically, I guess we should have done this before. The middle here, let's fill out this. Let's say this is 5, this is 7, 3, 2, 1, 0, 2, 3, 5, 8, and 1, 2. So here the possible centers, which are the possible centers? What are the possible centers?
5 or 7.
5 or 7. Let's highlight that. These are the possible centers. Now then, my initial calculations here are wrong because I was getting a number that was out of the possible center. So I said X, X is the rows. X is the rows. No, but X is. I'm getting tripped off on my X rows and calls. Anyone can help me?
Repeat the question, please.
I'm just getting tripped off about X. X being, yeah, I guess, yeah. So X are the number of columns, right? So X is this axis here. Oops.
Usually the first
rows.
X is that. And then this is Y.
Yeah, X are the rows and Y are the columns.
So then here rows, then this is Y. This is X and this is Y. Right? Now we have X and Y, then we are in X2, Y1.
I feel like it would be easy if we rename it to like CNR,
What do you mean CNR?
column and row.
Oh, like this, X instead of X and Y?
Yeah, so it'll be more transparent.
Actually, I think I agree with that. Let's do that. Instead of X and Y. So I guess the plural will be for the bounds, rows. And then we could just call this call, and then this row. And I'm just saying these two variables are just our bounds. That's the number of rows and the number of columns. Right? Yeah. I think I like this suggestion. Let me erase this. So these are just our bounds. And then we can have the row the column the row that we start at is just going to be equal to rows, which is 3 divided by 2, which is just 1. Then the column we're on is going to be 4 divided by 2, which is equal to 2. Right? That gives us a coordinate of where we have like x and y.
1, 2, 1.
So we're saying call first, which is 2. And we're saying row, which is 1, right? That gives us these two coordinates. Everyone following up until here? So that is column 2, row 1. It fell here. So in this case, we were lucky that in the middle of the possible middle, that is the one that has the highest value, right? Because the possible middles are 5 and 7. This square.
I have a question because why, if you have the column is 2 and row is 1, why is the possible middles 5 and 7? Why wouldn't it just be 7 since that's where it lands?
I think that's a good question. It will be about where there is no clear middle. Like there is a clear middle here, right? But here is like there's no clear middle per se. Like, you know, I guess it depends on, you know, if you're saying here, is this the middle of the matrix? I think it will be sort of subjective because there is 2 columns to the left and just 1 column to the right.
Alejo,
Yeah.
like I said earlier, to compare those 2 middles, you gotta take the ceiling of the result and the floor of the result, and you compare them.
I see. I think I'm starting to see what you were saying. Well, let's flip this around here. Let's say this was 5 and this was 7. So on the first one, we fell in here. We fell on 5. But 5 is just one of the possible centers, right? But the problem here says if there are multiple possible middles, then choose the one that has the highest point, right, to start on. So here we need to start on here instead of that one. We'll need to compare this one to this other one and see which one has the highest value to start on that one. Then how do we do that then? I'm starting to think about.
Do we need math 4 and math ceiling for that? It's like we have to choose either or, right? Mm-hmm. Whichever one is the highest one.
That's correct. I guess like what I'm thinking about is
would it work with? Yeah. Oh, I'm sorry to interrupt. Would it work with a simple if statement? Because we're at most we're looking at a choice between 2 or 4. Because if it's even by even, if it's odd by odd, then we've got a direct center. But if it's like we're in right now, it's odd by even, so it's a choice of 2. If it's even by even, it's a choice of 4. Is there something in that where we can check to start to see like what's our length of X versus our length of Y? And then once we know if that is even or odd, deduce what we need to start searching for?
I think we're going to need to do that. I think we're going to need to do that specifically because that's what I was thinking. What if we have more rows than columns? Here, the possible center is here, right? And then we need to pick not from left, like one on the sides, but actually top and bottom. And how do we take into account that? I think then Douglas' approach, we will need to look at the number of columns. Actually, Douglas, could you repeat what you were saying?
It was just along the lines of knowing if what we're looking at, if it's odd by odd, we have a direct center. There's no need to do any more searching. We know exactly where to go.
So let me take note of that. So is this odd?
3 conditionals.
Or by odd, we're good.
Right.
And here we're talking about, I guess let's do columns and rows. Keep going.
Just remember which one was columns, which was rows. Okay, no, it's all good. So if it's odd by even, where columns are odd and rows are even, then that means we're going to have, much like you have to the left there, it's going to be a choice of one above or one below, right on the middle split.
Wait, so if the columns are odd, no, the columns are odd is this example that we have here, right?
Oh, that's right. I'm sorry. Yeah, no, I swapped them in my head again.
Yeah, I know. I also have that problem sometimes, especially with X and Y. I was having that problem. So if we have a number, if we had an odd number of columns, then we know that the choice will be between like left and right, kind of. Oops. Let me then take a look here. Let me move this.
Also even by even.
Oh, even or even will be an interesting one.
That's 4 cases. I mean, like 4 boxes.
4 boxes. Okay, actually, I think we can. Let me also move this. I think we're close to something here. So odd or even, we said, well, I guess let's look at this example. We had an odd number of columns, and that means that I think the center will always be it will be greater than the previous value. So I guess like from here I was gonna say like row column -1, and then the row is just the row. Here, I guess what I'm trying to say here is if it's odd and even, like we have it here, odd number of columns, and even now I'm flipping them again. Yeah, no, actually, this doesn't go for this one. This goes for an even number of, I'm just gonna do even by odd. When we're talking about an even number of columns, we have 4 columns, and an odd number of rows. This applies to like basically check the first middle will be, the first middle that we calculate is this one, right? Which is column 2, row 1. The next middle that we should check is subtracting 1 from the column, right? So that is this one. So we started at column 2 minus 1, then this is the second possible middle. So let me do that here. Now the opposite is this case, where we have the opposite is this case where we have an even 0, 1, 2, 3, where we have an odd number of columns. This spells call, an odd number of columns with an even number of rows. Then the middle will be, oh, I guess we didn't calculate the middle of this one. What will be the middle without just doing sort of flooring it? What will be the middle that we get in here? I guess we just do, let's do rows. We said we have, well, Yeah, we have 4 rows, columns. We have 3 columns. So that means that the row that we get in the middle is going to be 2, right? 4 divided by 2. And the column that we get is 1, because 3 divided by 2, 1. So the middle that we ended up with is this one, right? Row 2, column 1. So in this case, then the other possible middle will be subtracting 1 from the row. So then let's do like row minus 1. I guess like this is what I'm trying to express here. I wonder if we could maybe do a table on this, now that I think about it. So this is like other middle. This is sort of the default middle will be 1, 2. Right? This is what we got here. 1, 2. The other possible middle will be if we subtract 1 from the row. So that's why I'm doing that there. So it will be the other possible middle will be just the same column that we got there, but row minus 1. Cool. Is that making sense so far? Okay. What if then is, what did we say? If it's even and even? So if we have something like, well, I guess
4 by 4. Yeah.
Then the possible middles are all of these guys. And in this case, do we need to pick then which one is the highest value here? Let's run an example here first. What did I do? Erase by area. I guess that's too much erasing. That's great. So here, what would we get if we do our calculations? 0, 1, 2, 3, 0, 1, 2, 3. We said we have columns. We have 4 columns. Rows, we have 4. This divided by 2, and that gives us our center column. It's just 2. Row is just 2. That will give us this spot here, right? That gives us that spot there. And now here I'm thinking about if I'm starting to wonder if the problem really requires this level of checking on what center to start. Do we have
Alejo,
Yeah.
I think it says n by m matrix. So n and m are different numbers. So I don't think it ever be even by even.
I think that doesn't exclude that case actually. N by, oh, because you said like if it was always the same, it will be n by n, or like n by like n by n basically.
Yeah. So n and m have to be different. I'm assuming, mathematically speaking.
Actually, yeah, I think I didn't think about that, and that is actually making sense, because here in the problem it says n by m. Well, actually, now I'm retracting, because m could be the same as n, and then you will have the perfect square, like in this case. So I don't think I was thinking about it, but I don't think saying n by m rolls that out actually. because it could be that n and m is the same, like in this case that we have in that we're drawing here. I think I don't know if is this Hungry Rabbit coding challenge, just to see if maybe it's like a LeetCode that we could try it later on. I don't think it's in any of those.
Lead code in the end of the result. Yeah, right there.
There is rabbits in a forest. Maybe that's the one. People just keep changing the name. No, this is a different one. Oh, here, something I was thinking about is like, you see how we got the lower corner, the right lower corner. So that means that if we do floor, we always get the highest. If we have an even number, we always get the highest center, and the lowest center in terms of this, right? We have here, when we had this even, we got the top, the bottom right corner. And here we always get the lower. We always get the lower or the greater one in here. Like we get the greater row of the possible, and same is true here. We get the greater one. So what I was thinking is that then we could maybe factor something in. I don't know why it's lower when I scroll there. Going back to like what we had here, if it's even and even, what we can do is just we compare the center that we got, which is going to be this one. And then what we need to do is then compare that center to here. We got this. We got 2, 2. What we can do is, remember, this is the column, this is the row. What we can do is subtract one from the rows and leave the column as it is. Subtract one from the row, then we got 2 and 1. So that will be this spot here. 2, 1. Then we did that. We subtract that one. The other thing we can do is subtract. We subtracted one from the row. Just subtract one from the column and leave the row as it was. So we get row as it was 2. We subtract one from the column is 1 and 2. So that will be column 1, row 2. So that will be this spot here. And the other one that we need to check is when we subtract 1 from both, right? Where we get 1, 1, then that's this other spot here. So here is, this is like row -1. This is col -1. And this is just both -1. I'm not sure if we will need to get to this point. But I think this is a good start. I think from here, let's start with this. Let's start coding this, and then move from there. Questions up until this point? So let's get back here. Now I'm starting to think about what Shara said, like want to start in the middle. Maybe that's something we can code in a function for now, like a separate function. I think it will be good for that. We could call this function like find highest middle. Right. That in this function we're gonna encode everything that we discussed here, basically about how to calculate the middle. Cool. So this function should return. What should this function return? What do you think?
7.
No, but I mean, yes, that's what it, in this case, that's what it should return. But like, should it return a string, a boolean, an array, an object, and with what?
The row and column.
It needs to return the row and column. How could we return a row and column? Calculate highest middle. I think calculate the highest middle. So what if we do, we're gonna do some math here, but what if we do, yeah, let's do this. Let's return an array with that the first value is going to be the column and the second value will be the row. Right? And these are going to be the middle. Once we figure it out how to calculate the middle, this is going to be the middle column and this is going to be the middle row. How does that sound? Okay. So here, this function is going to take in the matrix. I'm just going to abbreviate it as M. And then we said, going back here, that we could just do the divisions basically. So we said, let's let calls equal, the columns will be, the columns, if we think about it, the columns is the length of one of the inner arrays, right? The length of one of the inner arrays. So let's just pick this, the first one. This is the first inner array, which is this one. And we say that length. All right, and then we'll say let rows. The rows is then the length.
Arrays.
Say that again?
The amount of the arrays there are.
Right, so basically the length of the outer array or the length of the matrix itself. So we can just do m dot length. Is this making sense so far? Okay, and then we say, let's just calculate the middle. So we can say, actually, let's call this m middle row to be a little bit more descriptive. Middle row is going to be just equal to dividing the rows divided by 2. And we need to floor this, math that floor. Let middle column. Actually, let's just let to middle call. Same thing, but with the columns, the calls. And then here we're gonna return middle row, I want to return middle calls, like columns first. The columns will be our first value. The rows will be our second value. Middle row. Okay, let's see what this gives us for our input matrix. So let's do console log.
You need to put an S on rows.
Say that again?
You need an S on row.
Thank you very much, yes. Find highest middle, and we pass in our garden. Let's run this, see what we get. cannot read property 8 of undefined. Cannot read property 8 of undefined at line 10. Oh, I'm missing commas here.
Ah.
Spelling mistakes. Cool. So we get 2, 2. Why do we get 2, 2?
Those are the indices.
What was our example? This is our example. Oh, I guess I never coded this one. Here, let's run with this. I'm gonna save this garden. Let's have a simpler one here, the one that we had here. So this one is 8, 5, 3. And we have 0. Let's put 7 here, or actually, let's put 7 here, 5 there, 2 here, then 2 here, 3, 2, 1. So we have this picture, right? So we just have the drawing there directly. Let's run it again. Oh, this time we got 2 and 1, right? We got column 2, row 1. So if we look at the drawing here, column 2, row 1, then we got our 5, right? So that's fine there, but that is actually not the highest middle, right? We need to compare it to the other possible middle, so that we actually calculate we actually get the highest. Yeah.
I think 2 is the row.
We say, no, we say, look at what we're returning here. We're returning the first element, the column, second, the row.
Okay, forget it.
Yep. Other questions? Okay. So we get 5, and in fact, if we do here, if we do something like console log, let's say let middle element, and we say here, let's use array destructuring. I'm going to say let column and row. Do you remember how we do that in React, where we do curly brackets? We can do that with arrays too. And this is what that looks like. And we say garden at that column, that row, and we console log the middle element, which you get that 3. So here we have the same problem that I was having before. The inner elements are actually the rows. So this, we have to flip this here, row here, column here, because what we draw here as our picture, right? This row 0, row 1, row 2, right? Those are the outer sort of indices, and then we have the inner ones, which are depending on, which are basically what we call our column. So here I need to flip that, where you're looking at the second row, column 3, column 2, and if we run this, we get that 5. We get the element that is in our first calculated middle, right? Now here, no, this here is a little bit confused, might be a bit confusing, but this is no different from this structuring from state. When you say something like let username and password from this state, you have done that 1,000 times in React, right? This line. What this is doing is the username key and the password key of the state, right? This structure that. This is the same thing. It's just that it's with an array. They're saying the first element of the array and the second element of the array that this returns, right? And then we just named those. We named it we named it column, and the second one we named it row. Is that clear? Okay. So we have the middle. How we have about 5 more minutes. I think we can get to calculate the middle, the highest middle. So we have the middle, but we need to compare it to the other possible middles, right? And then we need to then take into account this thing that we were talking about here, about the odd columns, the odd rows. Any ideas about how to take into account that? What if, you know, we could just do some if statements. So here we have our middle. Let's do something. We need a way. I was thinking maybe we could keep the other possible centers in an array. But we saw that in this example, there is only one other possible center. And in this other example, there's one other possible center. Only when we have all evens is that we have the, here. Only when we have both columns and row evens is that we have the most number of other possible centers, right? You know what? Let's do it simple. Let's not worry about this case. We can come back to this case. Let's just think about this. Let's say if the number of columns, we said if the number of columns is odd, equals, let's say modulo 2, that's how we can tell whether a number is odd or not, is equal to 1, right? If the number of columns is odd calls, then what do we want to do? We want to do the other possible middle, which is, here, let's do let. Oh, I was gonna say another variable here for the other possible middle. Yeah.
I'm confused because if you use an map.floor, so like let's say column 3, using map.floor is going to turn it into 1. I don't get it. Why are there multiple possibilities?
Why are there possible?
Like column 2, row 1. Why would you still need to do an if statement if map.floor is going to take care of like the possibility of like 1.5 is going to give you column 1 and row 2 or whatever?
That's a good question. The if statement that I'm trying to do is so that we know here that when we have an even number of columns and an odd number of rows, the possible middle is this other 7. So the middle that we calculate, the first one is this one, right? That 5 one. And the other possible middle is this one to the left. But then that is if the columns are even and the rows are odd. And that flips around when we have the opposite. When we have uh, odd rows and even columns. Now here the other possible center is this other one here. And we do need to check both because the problem says if there are multiple possible middles, we need to pick the one with the highest value. Does that answer that question or?
All right, I think so.
I don't think so, but maybe if you could repeat your question.
Let's move on. I think I'll get it.
Okay. I think we are kind of running out of time. We will have to head back.
Hey, don't you mean they had to come here?
Oh yeah, everyone will just come back here. Yeah, because we didn't leave for a breakout room.
Alejo, look at my direct message to you because I found the answer online. I'm pretty sure N and M will never be the same.
Okay.
Because like even if you think about like variables in general, it will be M by M if it was the same. N and M have to be different.
Mm-hmm. Right. Even if it can't be, we still have to deal with this case, don't we?
Yeah, you're right.
We
In
still have
theory.
to deal with this case where we have two possible centers, two possible middles. That two possible middles will be like in the same column or in the same row. That will be based on whether we have the number of rows are that will depend on whether the number of columns is even or whether the number of is actually odd. Here, let's do this. What if we say let possible middles? We have an array. This array will have other arrays inside. In fact, it will have our initial array. So I think, oh, why did this refresh? So here, what we can do then is here, if we have all the possible middles in an array, then we can loop over them and check which one has the highest value, basically. Right now here, we have just our initial middle, the default, and we're saying if the columns are odd, if we have an odd number of columns, what we need to do is check here. This is the example where we have an odd number of columns. We're not even worrying about the actually, and this will actually also work for where we have 4 possible centers. But here we have an odd number of columns and we have an even number of rows. So what we can do here is what we were describing here. We could just say the middle column will be the same one. So let's push to the possible middles. Let's push this other middle that we're getting. Let's put the column will be the same one, but the row will be the middle row that we calculated minus 1. Note that here I'm literally translating from what we had written here. We're saying when we get this case, the default middle that we're going to get is this x here. The other middle that we need to check is going to be same column 1, but 1 row less. That is this one, right? We got 1 row less. The row that we were here was 2. The row that we're here is 1. And then we can do the same for the other one. If the rows are odd, we said if the odds are if the rows are odd, like in this case, in this example here, or I guess the opposite. Actually, we wouldn't need. We could do the if statement, or we could just do an else. Let's do the if statement. If the rows are odd, assuming that the odds being odd rules out the fact that the columns are also being odd. Oh, now I just thought about something. What if then if both of them are odd? In that case, if both of them are odd, we have a perfect center, right? That is when we have a perfect center here in this example. If both of them are odd, we have a perfect center. I guess that will be something else we need to account for. Let's just finish this one, and then as people start trickling in, we close up here. I feel like I would like to continue on this one. I'm not sure if maybe I'll continue the tutorial alone, and then you can just study it rather than dedicate another class to it. I want to send a poll like next week about maybe what to focus on next week, or what are some of the topics that you want to review, and so on. So here we said when the rows are odd, like in this case we have three rows, so we can check is the row will stay the same, but the column reduces, so we do -1. Right now here, let's return possible middles. And let's try this again. Oops, I cannot read property object of array. Oh, right. That is because then this is, we broke that. So let's say that middles equal middles, and let's just console log the middles here. And we get this. We get our two possible middles, which is, as we were saying earlier, 2, 1, and the other possible middle is 1, 1, right? And this is because, yeah, what we were saying there. Now from here, what we could do is then, okay, we visit each one of those locations, see which one has the highest value, and then we return that one. We return the one that has the highest value. So note here that something that, like, we're breaking this problem down into, I guess it's component problems. This was one of these component problems, like figuring out what's the middle of a matrix, how to get all of the other possible middles. The other problem will be, okay, now I'm able to figure out all the possible middles. How do I get which one is the highest? Which one of those possible middles has the highest value, so that we start with a rabbit there. Then from there, what we'll just do is just scan here, as we did here with this sort of cross. We're going to need, like, maybe we can call that function like a scan function that will return the coordinates for the highest value. Actually, it's going to be similar to what we're doing here. Let's calculate the possible other places that we can go, and also calculate which one has the highest value. And let's move our rabbit there and repeat from there. Any questions about what we did here, unless we sort of got a head start on calculating the middle of a matrix when that matrix may or may not have an exact middle?
This helped out a lot for me. I know it's pretty thick stuff, but I appreciate this.
Cool. I'm glad that it helps. Yeah, I think let me send a message on to the other breakout room. Um, breakout rooms. It's interesting that the way that you send messages to breakout rooms is different from the way you send messages like in the chat here. That will definitely improve the user experience. Yeah, I guess like something we can do here is, I think we have a problem if, yeah, I guess we fixed one problem, but we got another one, because if we have a perfect, a square that is odd, both where we actually have a perfect center, if we do this, look at what we get. We get that there is 3 possible centers. The one that we had, that like the actual one, the actual center, that we could call it like the absolute middle. And then because the rows were odd, and because the columns were odd, then we also get these other two, because that's what we're doing here. Where we subtracted 1, so column 1, row 0, so that will be this one. The other one will be column 0, row 1. So we get this as possible middles, but and that will be a case that we'll need to keep into consideration. I guess for that, we could just have an if statement here. If both of them are odd, just calculate one middle, because there's an absolute 1. We didn't see what happened if it's this odd. No. If it's this, do we get 2, 2, which will be 0, 2, 0, 1, 2. Right, here is going back to this example that we have here. Right, we get 2, 2, which is this, literally this one, 2 and 2. Right. And then from there we can do we kind of have it flipped. Yeah, I think what I will do is I'll finish this maybe tomorrow, and I'll upload the video to YouTube so you can watch it. But picking up from where we are here, I think this is a really interesting problem that I was thinking of. Maybe it could also even be solved with some like object-oriented programming, where we have like a class called Rabbit, and that the class that Rabbit has a method on maybe scan, maybe another method eat, another method move, and stuff like that. It will be more model than what we will have here. But I definitely want to sort of share a full approach for this problem. I don't know then, like, where is everybody else? me share this in here in the chat. Let me go back. Let me go to the other room. I'll be back.
Cell, and for each of them, you are executing the operation, and you're saying, add this I thing, that operation, add this operation to the appropriate places, and then you're just saying, is it undefined? Is basically what you're saying.
Wait, which line are you looking at? Like this line here?
So this plus one, this plus equals, dude. When you call plus equals, you're calling it on truth, right? The thing on the right is true, right? Because grid is.
Yeah, I was playing with that, but
and that just works. That just
it
works because
works.
true is one.
Yeah, like it's really weird.
Can you open up your console? Can you open up your console right now? Just your JavaScript console really quick.
You want me to put a console log on something in it?
Yeah, just go to the console. Just really quick, go to the console. I just want to just test something. This is just weird JavaScript shit.
Yeah,
Option 9.
Is it really checking all the neighbors?
Yeah.
How? With a for each? I don't understand that for each.
Okay. And then, can we just go to the console really quick? Really quick.
I just want to say,
like, what's up?
I just want to say, I hope everyone has a good weekend. Ben, thank you for helping. And see you all next week.
Yeah.
We'll see you Saturday.
Thank you.